Hey there, I'm Kathryn Grayson Nanz, and I'm a developer advocate for Progress Software. Today, I want to dive into a topic that I love, but that might not be a favorite for other folks: CSS. CSS gets a bit of a bad rep, but the truth is, it's changed a lot in the last decade, even just in the last few years. In the old days of web development, if we wanted to create websites and applications that were responsive, it meant writing a series of media queries based around specific device breakpoints, and then reworking our content for each size. And yes, before someone says the truly old days of web dev were table-based layouts, I do remember those, and they sucked too. CSS frameworks stepped in to try and ease that device breakpoint pain point. We saw things like Bootstrap and Skeleton get really popular, all because writing all of those media queries was a lot of work. Slowly, we saw best practices around writing media queries shift, by necessity, from device-based breakpoints to content-based breakpoints, as more and more devices came out in all shapes and sizes. Now, with screens available in pretty much any configuration you can imagine, it's time to shift our approach once again. The era of breakpoints is over, and the era of fluid design is here. Rather than hitting a point and snapping to a new layout, our content should always be adjusting based on the amount of space available. Thankfully, CSS has also come a long way since then, but a lot of us got used to just throwing in a media query or 5 to make things responsive, and we never quite broke that habit. Now that we have modern CSS features like grid, flexbox, calc, clamp, and aspect ratio, in 2022, it is finally time to ditch the media queries. Today, we're going to start at the top and work our way down the cascade, from the big picture display formatting all the way to the smallest units. And as for your old style sheets, we can refactor. We have the technology. Let's start with some of the most popular responsive display options: Grid and Flexbox. They've been around for a minute, with Grid hitting full browser support in 2017 and Flexbox in 2013, but a lot of folks still don't fully understand the difference between them, or when they should use one versus the other, or combine them. Many people assume a false equivalency between the two that can create a kind of misguided either-or approach to choosing a tool, when in reality, they not only have very different use cases, but also can and should be used together to complement each other. For our purposes though, let's focus on how they work and how you can use them to handle the layout of elements on your page in a way that will allow for natural wrapping and responsive adjustment without the need for media queries. Grid is primarily focused on, creating a grid with multiple rows and columns that you can then populate with elements. You do this by creating a container grid element, which you then fill with child elements. There's a truly huge number of customizations that you can make to the grid rows, the columns, the cells, all of which allow you to create grids as simple or as complex as you can imagine. But for our goal of creating simple, responsive designs, let's take a look at some of the most relevant features. Grid comes with the ability to repeat columns or rows automatically, as well as autofit, which will automatically size your columns into the available space. For example, this code here. In this situation, the grid will turn your content into columns, which naturally fit in the space that you have, with each column taking up a minimum width of at least 300 pixels and a maximum width of no more than 1 fraction. That 1FR there is a new CSS unit that stands for fraction, and which tells the browser to divide the space evenly, give each column 1 fraction of that space. In this case, it will create 3 equal columns that take up a third of the available space, but will never get smaller than 300 pixels. Let's switch over to a live example here so you can see how it works. Were we to add another div, like so, you can see that it's gone ahead and added it, but because of the space constraints, it wrapped it to the next column because there's not enough room for all of them to be 300 pixels. But when the screen is wide enough, it automatically jumps back up. So we can see, as we resize, our columns auto-fit to the space available. If you're looking to create a more complex layout using Grid, here are a few of my favorite reference resources. A Complete Guide to Grid offers a fantastic breakdown of all the ways you can customize your grid, including creating columns of varying widths, setting template areas, setting the gap between grid cells, and so much more. Grid by Example is my favorite place to start when I'm looking for a jumping off point on creating a new grid structure. And if you're looking for a real-world example of a complex grid, you can check out the frame.scss file in my Kendo demo app, where the CSS grid was used extensively to create the menu frame used on every single page. Flexbox takes a similar, but not quite the same approach to helping you lay out your elements on the page and then adjust them automatically as needed. Rather than creating a full grid with multiple rows and columns, however, Flexbox is all about the positioning of child elements relative to each other within a single parent element. Basically, if you need to work in two directions at once, rows and columns, you should be looking at Grid. If you need to focus on one direction, a single row or column, that's where you'll want to reach for Flexbox. Again, there's a lot to look at in terms of when to use each one and what the differences of application are, but let's leave that for another time. For now, let's focus on how Flexbox handles responsiveness for you, so you can delete that unnecessary media query. The main point of interest for this is the Flex Wrap property. Flex will start by attempting to fit everything you've written into one row or column, but if that isn't going to work, you can tell Flex to allow wrapping by setting Flex Wrap to wrap. If Flex Wrap isn't specified, or set to no wrap, Flex will squish the elements to keep them all on the same line, if no min width is specified for the child elements, or it will allow them to overflow out of the view if you have set a min width on the child elements. Let's go take a look at this in a live example as well. Here you can see it's not auto-filling the entire width of the page the same way that the grid example was. We've got each one of our child divs set to a width of 300 pixels, and because they all fit, they're all here in a nice little row. However, we have set Flex Wrap to wrap, so as the screen gets smaller, it will drop each one down to create a column even, if we get it skinny enough. Basically, with both Grid and Flex, you just have to decide whether you want your content to squish or to wrap, and then set your properties accordingly. Both are really great tools to have in your toolbox for creating responsive UIs. If you're looking for some resources to master Flexbox, here are a few of my favorites. Flexbox Froggy is a great game that will help you master what all the different properties do, all the while using some adorable frog illustrations as you try to match up frogs with their coordinating lily pads. And then Flex is a simple visual cheat sheet that's really good for referencing while you're working. If you just need to look up something real quick or can't quite remember the syntax, this is a great reference to have on hand. Once we've got our general layout in place, it's time to set some specific properties on our elements. And good news, no media queries are needed here either. Did you know that there's a CSS property specifically designed for aspect ratios? This is especially useful if you're dealing with video or big hero images, where keeping that correct aspect ratio is super important. There's a really good deep dive on this on CSS Tricks, but in general, it's pretty easy to apply. All you really need is that one line that defines the aspect ratio. If you set a specific width value along with your aspect ratio, it will use that as a basis and automatically generate the height value to match, or vice versa. However, if you declare both a width and a height, it will honor those over the aspect ratio you set, so be careful. Although min and max height and width properties can often be replaced in many use cases now with the clamp function, which we'll look at next, there are still really good, valid cases when you want this CSS, and it's important to still kind of have it in your back pocket. They're also really easy to understand, since they pretty much do exactly what they say on the tin. Here in our example, we have an image that we're telling first and foremost to take up as much space as it has available. So we've set our width to 100%. Then we're giving it some guide rails. We don't want it to take up more than half of the container, but we also still want to make sure it's larger than a postage stamp, so we don't want it any smaller than 200 pixels wide. In this case, we set an absolute value only on the small end, because we're able to look at the image and know exactly how small it can get before it becomes unrecognizable. Now, no matter how the browser is resized, we know that our image will always be as big as it can be without getting either ridiculously giant or unreadably small. Math functions are a newer addition to CSS and incredibly powerful. They fill a void that CSS developers had complained over for ages, the ability to compute values within style sheets and set ranges for properties. The sooner you can master them and put them to use in your code, the more you'll benefit. Clamp allows us to set a base value for a property, along with upper and lower caps to contain it as it adjusts. This is one of our best tools to ditch the media queries, as it allows us to set those responsive limits without needing to define specific breakpoints to do so. Here's how it works. The syntax is open parentheses, set your minimum value, set your base value, and then set your max value. What we have here is an updated version of our last example, that image with the min and max widths. Only here, we're doing it all in one line using clamp by telling the image to take up 100% of the available space as the base value, but never larger than half of the container size, the max value, or smaller than 200 pixels wide, the min value. If you have ever looked at CSS and wished that it had just a little bit more math, then Calc is for you. It allows us to do simple arithmetic with CSS units right in our style sheet. This is great for when you need to base something off of a unit that's not absolute. You can also use CSS variables in your computations, which makes them extra flexible. So let's say that we want to create columns that are evenly divided based on the current width of the browser. Setting 1/3 widths used to be kind of difficult using percentage units because there was that whole 0.333 repeating situation. But now we can just say, you know what, CSS, you handle it. Here we take the full window width, divide it by 3, and then set that as the max width property of the child element. If you are a fan of having your style sheets handle as many decisions for you as possible, allow me to introduce you to min and max. They work very similarly to clamp, but rather than setting a range that moves in both directions, it focuses on just one at a time, allowing us to set the smallest or largest value depending on how the math works out. Again, this is a super useful tool for handling those non-fixed values, and non-fixed values are something you have to deal with a lot when you're creating something responsive. In this case, we're setting the widths for two different images, one that we'd like to keep small, and one that we'd like to be large. Min will evaluate whether 200 pixels is greater or lesser than 30% of the current container, and then choose whichever value is the smallest. Max, on the other hand, will make that same comparison between 50 VH and 800 PX, and automatically go with the larger. It's all well and good to think about things from a bird's eye view, the way we need to when we're laying out elements on our page, but we also can't forget about the little guys, the units that specify size for our various properties. When we set everything in hard or absolute units, like pixels, then we have to go in and adjust it manually each time we need to resize it. But when we learn to work in responsive units, we can let them do the work for us. Two of my favorite and most used responsive CSS units are VH and VW, viewport width and viewport height. Although there's no percentage sign, VH and VW are really a type of percentage-based measurement. One VW is actually 1% of the viewport width. Gone are the days when viewport measurements had to be obtained via window.innerWidth or window.innerLength. Again, dark times. We can now get that information automatically in our style sheets. They'll also update themselves as a user resizes the window, so there's no hoops to jump through there either. VH is especially useful for those times when you want to center something vertically or stick something to the bottom of the viewport, like a menu. So to create a container element that's always the exact height and width of the user's current browser, all you need is this code, height 100 VH, width 100 VH. If you are still defining your font sizes in pixels, please let me tell you about the beauty of rem and em units. The name em actually comes from the old typographic standards of measurement, based around the width of the letter M in each font. That's also, by the way, where the words em dash or n dash come from. Those are dashes equal to the width of the M or N characters. M units are a way of defining your font sizes relative to the font size of the parent element. So you could do something like setting font size to 2.5 M, and that would set your headers to 2.5 times the size of the body font in the parent element. Rem, on the other hand, allows you to declare your font size relative to the root font size of the entire page. In fact, that's what the R stands for, root. Both Rem and M work in the same way. The difference is what they're using as the base size and what they're scaling based upon. In general, I prefer to lean towards Rem over M because I like the consistency it creates. But if you need a specific design in one area that differs from your overall style, M is going to be what you want to reach for. And if you're looking for a really neat trick, you can combine VW with Rem and Clamp to create a fluid typography system for your whole application. In this example code, we set the base font size to 2.5 VW, remembering that 1 VW is equal to 1% of the viewport width. Then we set min and max values on either side to ensure that you don't end up in a situation where the text becomes unreadably small or a situation where the text just keeps getting bigger. This way, the font will automatically resize based on screen size, but within a set of limits that we've determined to be reasonable. And last, but certainly not least, we have the humble percentage unit. If you're going to be setting widths by hand for almost any reason, as opposed to using a layout tool like Grid or Flex, then you will almost certainly want to reach for the percentage instead of any absolute measurement unit. This probably isn't one that you needed an example on, but just in case. Here we have an element that we're setting to be 1/4 the width of its parent. As the parent width changes, this element will automatically adjust as well. It's simple, yes, but percentages are truly foundational for building responsive UIs. When we're talking only about responsive design, then it's pretty safe to say you can ditch the media queries. However, there are some situations not related to responsiveness where media queries are still the way to go. So before you throw them out entirely, let's touch on a couple examples where your old friend @media is still going to be your best bet. When it comes to ensuring that your app or site is accessible, media queries still play an important role, especially when it comes to the prefers media features. The most widely used of these are prefers reduced motion and prefers color scheme, although there are still a few others in the experimental phase, such as prefers reduced transparency and prefers contrast. With the user preference media features, we can adjust our content based on the user's system-level settings in order to adjust our layouts to be more accessible and user-friendly. These are especially important because it doesn't require the user to load an inaccessible page in order to change their settings. For example, if a user has already enabled dark mode in their operating system settings, and we're using prefers color scheme, the user doesn't have to load our application in light mode and then go change settings in our preference menu, since prefers color scheme will detect that. So to a user, it feels intuitive and completely automatic. If we need to change how an element on the page looks or works, or simply remove it entirely, there's still no better tool than media queries and breakpoint-based changes. A common example of this is the switch from a list-based navigation menu to a hamburger menu on small screens. Because we need to actually hide and show whole elements of the UI as part of this switch, like not showing the hamburger icon when the screen is larger, we still need to use media queries to handle that swap. If you've never had to worry about styling something on your website or in your application for print, then let me just be the first to say congratulations. I, for one, am jealous. It's often a difficult task to take something intended for screen-based viewing and reformat it for paper. But when it's a task that we have to take on, media queries are there for us. By specifying print, we can define a whole new set of styles that will only be applied to our layout when the user chooses to print the page. It's not exactly cutting-edge new technology, but if you're working on an application that provides information that users need when they're not at their computers, it's something we can do for them that can greatly improve their experience. If you're still relying primarily on media queries to ensure that your site or app is responsive, it might be time to take a look at everything CSS has to offer now See if you can swap some of those old-fashioned breakpoints out for these new, fluid approaches to styling. Working to create a fully fluid layout means less drastic changes for your user when they move between mobile and desktop, as well as less maintenance work for you. No more updating every single breakpoint every time there's a change to the design. Leverage these adaptive approaches to styling and get ready to just go with the flow. Here's to another year of building great stuff for our users. Happy coding and happy 2022!